that answer.
Sorry, Mark. Check 1, 2.
Check, 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 check. Okay, shall I start,
Yeah,
Eric, if you don't mind? Welcome everyone to our webinar Optimizing EV Charging, Fluke Solutions for Efficiency and Sustainability. I'm Mark and I'm joined by my colleague Eric. In the next 30 minutes we will explore how our Fluke e-mobility solutions can transform your EV charging infrastructure. A few weeks ago we asked in a post, what burning questions do you have for us? Today we will be addressing them. And the first question is from Jeff. What is a charging station? Eric, can you enlighten us?
Sure, Mark, that's not a problem. So a charging station, well, there are various names for that. So like an electrical charging station, an AC charging point, but the official name is an EVSE. That stands for Electrical Vehicle Supply Equipment. Very fancy word for a box like this. But what it does, it recharges your electrical car. But if you take it to the bare bones, it's a very fancy electrical socket. And the socket like this one here is just a 3-phase socket. However, controlled by electronics to make sure that the charging goes the way it should.
Thank you, Eric. The next question is from Eva. Why test a newly installed charger in the first place?
That's a good point, Mark, because you would think these things are out of the factory working as should, but you are building a system with it, so you have to check its functionality and its safety. So, bottom line is, you are extending an electrical circuit with a new socket, the same as you would extend an annex that you have in your building. And there are some requirements. It's not us telling us what you should do, but this is the requirements like the IEC 61010, the VDE in Germany, the NEN in the Netherlands, the British Standard in the UK, that tell you exactly what you need to do. You need to test if the functionality is there and the safety is there. That's why you need to do this at the new install as well.
Our third question comes from Daniel. How do you actually test for safety?
That's a very good question, Mark. We cannot do this with our bare hands, so we need instruments. And if you use instruments to check the safety and functionality of electrical installations, which is a part of this one as well, you need instruments that are compliant with the EN 61557, meaning that they test all in the same way. So minimum you need to test is protective earth. Of course, you start there. Something goes wrong, you need to be sure that at least an earth connection is there. Second, this is outside, long cables, underground cables. So insulation testing is very important as well, because you never know what the state of your cable is. Then we are in the box itself, and in the box you will find, or also in your distribution panel, you will find RCDs, so residual current devices. These detect potential leakage currents, so it will switch off if something goes wrong. But in your mind, this is a car. A car has batteries, which is DC. So DC leakage currents also can occur. So EVSE like this will have an extra device in there. It's called an RDC-DD that will detect those DC leakages. That's a functionality you have to check as well.
The next question for today is from Sarah. Do you need a lot of tools like a multifunction tester, or can you also test in another way?
Well, it depends, Mark. So it depends on what you want to do. So if you take the lineup of tests that you need to do, like protective earth testing, well, this is an insulation tester. You wouldn't think this is for a protective earth. But protective earth is a resistance measurement testing that, according to the EN 61557, you need to do with 200 milliamps as a minimum. This happens to have that test on board. So you could already do 2 different tests with one device. However, these are also RCDs in there. How do you test that? It won't work with this one. So then you need a different device. And also, if you want to do testing, you need to access the parts. Well, how do you put your test probes on this socket? Which is going to be difficult as well. One thing to remember, this device is inactive when there is no car attached. So imagine yourself a car being attached to this device. Where do you put your test leads? So it really depends on what you want to test and what and how you want to test. So most persons will take a multifunction tester together with an FEV adapter. So technically you could test this also by opening the box. But if you do that, you opened a weather-sealed box and you are exposed to live parts. And if you want to do that, you need a few things. You need to have your safety glasses on top of my glasses. Of course, your gloves needs to be there as well. And then you need to take your test leads, your device or devices, more than one maybe. And then being exposed in the elements to live parts. Is this really the most efficient and the most safe way? Maybe not. Maybe this is better. So this is a Fluke multifunction installation tester together with an FE300 that will take you through all testing in a safe, efficient and faster way.
Thank you for your insightful questions. They provide a great segue into why choosing the right solution for EV charging infrastructure is essential. Eric, let's delve into why our viewers should opt for our offering of Fluke e-mobility solutions for their EV charging infrastructure needs.
Good point, Mark. So, electric vehicle chargers are being installed and tested by the same customers who are using the Fluke products already for a long time. We are in the business for 75 years, creating reliable, easy to use and safe products. So with the FE300, we now have an addition to the family that actually interfaces with the charger to mimic the car and gives you an efficient way to test with a multifunction tester like you see here. The multifunction tester is already in the market for a decade or more and heavily appreciated by our existing installers. In the end, you will see a report out of this because you want to sign off on the safe use of your charger. And the TrueTest software is the part that binds everything together. It doesn't stop there, because if you want to have a maintenance cycle on these devices, you also need to be able to troubleshoot. Also, the FEV is a help there because you also can connect it to a multimeter or a scope meter to troubleshoot potential issues in devices like this.
Eric, why do businesses and individuals need these solutions in the EV charging industry?
Well, as I learned when I got my own charging stations, these companies are really stressed for time because of the huge demand and the expansion of the EV infrastructure. So this might lead for installers thinking to skip testing, but that's never a good idea. Better to test fast and economical than to not test at all and be sure that you leave a safe installation. Coming back for fixing issues or fixing unsafe situations will actually create more time loss and more money loss. So our FE300 in combination with our multifunction tester and TrueTest software ensures that companies can confidently sign off on a successful installation.
Eric, now let's spotlight on Fluke's e-mobility test tools and their role in ensuring the ongoing reliability, the safety and performance of EV charging solutions, and what's in it for you?
Well, Mark, what's in it for you is that you can do more tests in less time. That's where the profit is. With the TrueTest software, you also see the whole history of all your measurements, but also the ability to have reports according to local requirements. Since EV chargers are basically AC outlets accessible to the public, it also means periodic testing is required. So with the same equipment that you already have, you can also perform those measurements as well in the same software, so the full history of your work is visible. If something is wrong, you are in the maintenance and troubleshooting phase. No need for new equipment. The same FE300 with the ports on the top allow you to do troubleshooting measurements, for example, with a scope meter or a multimeter, without opening the EV charger and running the risk of being exposed to live parts.
Eric, let's explore Fluke's e-mobility commissioning solutions and their significance in ensuring the proper setup of EV charging stations.
Sure I can, Mark, but could you go to the main panel to help me out?
Yeah, sure.
Okay.
Yeah.
So, the panel is off. That means we can first do the safety tests for protective earth and for insulation testing. For that, we need to actually hook it up to the input port and connect your protective earth connection here on the meter to the protective earth on your installation tester. Switch it on, of course. And the other side is your main earth rail. I already prepared it here with a dedicated wire, which I plug into my installation tester. So now I have a connection made from the protective earth here all the way back to the main earth rail. By pressing test, I can check if the resistance value is low enough. In this case, it's okay. So that means I can proceed to the next test. That means an insulation test to see if the wires coming from the charging station all the way back to the contactor in here are okay. In this case, it is not really needed because you have only a short piece of wire. But if you have a fixed wire, this is a test that actually makes sense. So in that case, I can take this wire out and I put my red wire in again. And I will conduct the insulation test between the phase and ground for everyone. So I will go for the first one, which passes, which is higher than the limit required. I will go to phase 2, the ground. I will test it. This is okay as well. And I will go to phase 3 and test it. And this checks out as well. So protective earth is okay. Insulation is okay. So now it's time to actually power up the unit. So Mark, can you switch on the power? So we now have power, but we don't have power on the output because there's no car attached. This is where the FEV strength comes into play. So two devices needs to be tested next to the loop impedance is the RDC-DD, so the 6 milliamp DC leakage current device, which is in here, but also the normal RCD, which is in the main panel where Mark now is located. So how do we do that? First of all, we need to tell the unit that the car is attached. So I will switch from A to B. It means there is a car attached to the charger. It now engages the lock. I cannot take it out anymore. Then the car needs to tell the charger, I'm ready to be charged. So I go to C. You will hear the contactor click, and now I have an active output on my FE300. So now I can actually perform the test. I already set it up for a 6 milliamp leakage current. I will test for switch time. And you see it will actually switch because it detected a leakage current, a DC leakage current, and it did this in less than half a second, which is well within the specified time. So how do we do then the next one? For level, I will take out the car, but conveniently I only have to do that with the button. I don't have to take out the actual car. And I will put the car back into normal position. So now it's active again. Now I can perform the next test. And this is the level. Since this is a very slow ramp, this could take up to 30 seconds. Normally this takes about 10 seconds. Everything is okay, and it's switched at 5 milliamps, which is well within the specified 3 to 6 milliamps. So this is the RDC-DD device. What about the actual RCD in the main panel? That is the next test. So we are going back to the position of time. We are going to disengage the car, and we're going to set up a normal RCD like you also do in a normal building situation. Same thing here. Put the car back in, ask for a charge. Everything is active, and I can test the actual RCD, but now you see a different behavior. Now the whole thing switches off. Why? Because the actual RCD in the main panel now engaged. Mark, can you switch it back on? Thank you, Mark. So now it's back engaged, so I can do the level test as well. So I will put the car back into the socket. I will ask for a charge and I will press test. It's switched at 21 milliamps, which is well within specifications, and you see again the unit is completely off because the main RCD tripped. Mark, can you put it back one more time? Thank you, Mark.
You're welcome, Eric.
So now you can see I will switch off and take out the car. All functions are tested. So we covered protective earth, checked out. We checked the insulation test, all fine. We checked the functionality of the RDC DD, and we checked the functionality of the normal RCD. So all safety features are now tested, and if we create this into a nice report, we can sign off on this charger here. This concludes a completely rundown on the FEV for two things, which have nothing to do with the installation tester. So Mark, as you can see, there are two buttons here.
Yeah.
Because also the charger itself has two safety features. One is the absence of a protective earth, which is a soft fault. If I press it, you can test the functionality of the charger itself. For of course I have to switch it on and activate. When it's active, I press, and as you can see, it will switch off. You can also hear it, and if I release it, it switches back on.
Yeah.
The other one is if there is the control signal, so the communication between the car and the charger is faulty or short-circuited, that's a hard fault, then the unit should switch off completely. And that works as well. So now we truly have tested all safety features of an electrical charger. That's it.
Brilliant. Okay, thank you. Thank you, Eric. Thank you all for joining us during this webinar to explore Fluke Solutions further and understand how they can be tailored to your specific needs. Please get in touch with us by going to our website, fluke.com.
Introducing the Fluke FE300, the solution for testing the function and safety of AC electrical vehicle charging stations. Equipped with both Type 1 and Type 2 connectors, it's perfect for extensive testing on Mode 3 charging stations, commonly found in both public and home settings. It is compatible with both a panel mount socket outlet as well as with a fixed cable. The FEV300 is loaded with features such as emulating an electric vehicle, which allows the FEV300 to replicate a charging cycle for precise results. With its proximity pilot state rotary switch, it simulates various current capacities of the charging cable from 13 amps to 63 amps. The control pilot state rotary switch allows simulation of charging states A, B, C. It also integrates a PE pre-test feature for testing voltage presence on the PE conductor. Furthermore, the FEV300 is compatible with the 1663 and 1664 FC multifunction installation testers from Fluke, which allows for a variety of safety measurements. This integration facilitates quick and easy testing of RDC-DD, providing additional protection against 6 mA DC leakage currents on charging points. These safety tests, in line with international standards, ensure charging stations adhere to the highest professional standards, safeguarding users and reinforcing your reputation as a thorough and dependable electrician. Now, let's explore how to use the FEV300 in combination with an installation tester. Set the left dial to the charging point's maximum current. Set the right dial to vehicle status A. Connect your installation tester to the FEV300 and then connect the adapter to the charging point. Set the right dial to vehicle status B, which signals the charger to lock the plug. Wait a few seconds to allow the charging station to stabilize. Then set the right dial to vehicle status C. The charger will activate the charging output, which is indicated by the LEDs on the FE300 adapter. Carry out necessary electrical safety testing according to your country's installation test standards. Simulate protective earth error and control pilot error by pressing the respective keys. Ensure the charger stops charging when errors are present. Lastly, test condition D, charging with ventilation. Rotate the dial to status A, then B, all ready to charge. Finally, select status D. As most charging stations do not provide charging with ventilation, the charging station should show error condition and the charging output should not be activated. Fluke is here to empower your EV safety. With the Fluke FE300 and the 1663 and 1664 FC installation multifunction testers, you ensure reliable, compliant and secure EV charging infrastructure.